Hello everyone. Today we'll be learning about surds. So what are they? Surds are irrational roots of a positive integer, and they must be irrational numbers. This is what a surd looks like. There are three parts of a surd: the order, the radical, and the radicand, also known as the base number. The order tells us what to root by. For example, square root and cube root. The order will be the square and the cube. The radical is what identifies the surd, and the base number or the radicand is what is being rooted by. So another phrase for this can also be the nth root of a. So, as stated before, surds must be irrational numbers. Therefore, the square root of 9 and the square root of 25 are not classified as surds. Since they can be equal to 3 and 5. Examples of surds are square root of 2, the cube root of 13, and the square root of 23. So the basic rules of surds. So the power rule, the multiplication rule, and the division rule. This just tells you how to multiply and divide with surds. For addition and subtraction, they don't have a rule, except to add and subtract surds, all you need to do is make sure they have the same order and the same base number or radicand, and you can just add and subtract like in algebra. So now let's go and do some practice questions. So here we are with the practice questions. So our first question is the square root of 2 multiplied by the square root of 3. From the basic rules before, we can use the rule of the square root of x times the square root of y is equal to the square root of x times y. And now we can just substitute 2 into x and 3 into y. And here we'll have the square root of 2 times 3, which equals to the square root of 6. On to the next question. We have brackets, so we need to expand them by multiplying the square root of 3 to both terms. And using the same rule as before, we can get 3 to the square root of 15 minus the square root of 18. And with the square root of 18, we can factorize it to make it the square root of 9 times the square root of 2. They're still exactly the same because 9 times 2 is still 18. We do this so that because we can simplify the square root of 9 into 3. And therefore, our answer will be 3 to the square root of 15 minus 3 to the square root of 2. We cannot simplify this any further because the base number of these two terms are different. So this will be the final answer. So the next question is really similar to the first one we did. Except here, there are two ways of doing this question. One is by multiplying 8 and 27 first, or we can do the easier and more convenient way of first factorizing it and then multiplying both terms. If we do the second option, we'll get square root of 4 times the square root of 2 multiplied by the square root of 9 times the square root of 3. the square root of 4 and square root of 9 can be simplified into 2 and 3. And after that, we can just multiply them all together. And we'll get 6 to the square root of 6. And that will be our final answer. On the next question, it's the same as before, but the first option of multiplying 98 by 300 first will be extremely inconvenient and take a long time because it'll be hard to factorize much larger numbers. Therefore, we should just simplify or factorize these two terms first and then multiply. If we factorize the square root of 98, we'll get square root of 49 times the square root of 2, and square rooting the square root of 300, we'll get square root of 100 multiply the square root of 3. And 49 and 100 can be turned to 7 times 10. And the rest is still the same. And our final answer will be 70 and the square root of 6. Cubing things in brackets will mean we have to do it to every single number, even if it's multiplying to each other. So it will become 2 cubed times the square root of 3 cubed. This will result in 8 and the square root of 27, which can be simplified into 8 times the square root of 9 times the square root of 3. The square root of 9 can be turned to 3, and 8 multiplied by 3 is 24. So the answer is 24 and the square root of 3. In the rules we looked at before, this can also be written as the square root of 27 over 3. So we do the division first. 27 divided by 3 is 9. And as we know already, the square root of 9 is 3. Therefore, the answer of this question is 3. And on our last two questions, here we simplify the numerator and denominator first, and then we will divide both. So for the numerator, we have 5 times square root of 9 times the square root of 3 over the square root of 25 times the square root of 3. Sorry, this is meant to be square root. And here we can simplify the square root of 9 and 25. So we'll get 15 and the square root of 3 over 5 and the square root of 3. 15 divided 5 is 3, and the square root of 3 divided the square root of 3 is 1. So it's 3 times 1, which equals to 3. So the answer of this question will be 3. On our final question. So for this triangle, we have to use Pythagoras' theorem. That is a square plus b square equals to c square. So if we identify the sides of a triangle, this is A, this side is B, and the hypotenuse, the longest side, is always C. So we know both C and A, so to find B, what we have to do is c squared minus a squared, and that will equal to b squared, but we want b, the exact value of b. So we have to square root the whole thing. So if we substitute 8 into c, we will get square root of 64 minus, and if we substitute 2 and the square root of 7 into a, we will get 4 times 7, which is 28. So 64 minus 28 is 36. So therefore the square root of 36 is 6. And b will be equal to 6. And that is our practice questions. I hope you learned something new, and if you have any questions, put it into the comments down below. Thanks.